we're now going to use the scalar product in a different way, and we're going to use that to work out the angle that sits between two vectors. So we're going to use the first formula that we looked at, because that formula has an angle in it. So that's A dot B equals the magnitude of A times the magnitude of B times cos of the angle. So what we can do is we can rearrange that formula for cos theta. Okay, so I'm going to have cos theta, and then I'm going to divide A dot B by the magnitudes of A and B. Okay, so we're not given that formula, but it's not too difficult to rearrange that. You can use the formula in the first form, and then once you've got your numbers in, rearrange it. It doesn't really matter. Okay, so we'll do a couple of examples. This is a really popular exam question and will come up every year. It's not a terribly complicated question. The skills involved are straightforward. However, there is a lot of working out, but that does mean it's worth a lot of marks. So these should be quite easy marks to gain in an exam. Okay, so example 1. Calculate the angle between vectors P and Q, and they've been given to you in basis form. So the first thing we're going to have to do is write down the components of P and Q so that we can go ahead and work with them. Okay, so the components of P are going to be 3, 2, 5, and the components of Q are going to be 4, 1, 3. So I'm going to write down my formula, and I'm going to use the letters that are in the question. So instead of A and B, I'm using P and Q. Okay, so I've got quite a bit of working out to do, so I'm going to do that at the side here. You don't have to, but I've written down my formula at the left hand side here, so I'd quite like to just keep that separate. Okay, so the first thing I'm going to do is I'm going to work out the magnitude, not the magnitude, I'm going to work out the scalar product. So I'm going to work out P dot Q. And for that, I need to use the second formula. So I'm going to be doing 3 times 4 plus 2 times 1 plus 5 times 3. So that gives me 12 plus 2 plus 15. So that's 29. Okay. The second thing I'm going to do is work out the magnitude of P. So that'll give me the square root of 3 squared plus 2 squared plus 5 squared. So 9 add 4 add 25. So that's root 38. There's no need for me to simplify that or turn it into a decimal, just leave it as it is because it's just something we're going to plug into a formula, so don't worry about trying to simplify the third. Okay, and the last bit of working out is the magnitude of Q. So the magnitude of Q is going to be the square root of 4 squared plus 1 squared plus 3 squared. So 16 plus 1 plus 9. So that's going to be root 26. So what I'm going to do is I'm going to substitute those 3 parts into the correct spaces in the formula. So P dot Q on the top line will be replaced with 29. The magnitude of P is replaced with root 38. And the magnitude of Q is being replaced with root 26. Couple of options here. You can work out what 29 divided by root 38 times root 26 is and then do cos inverse, but your calculator will allow you to do cos inverse of all of that. So it's entirely up to you what strategy you want to employ in your calculator. I tend to just go straight to this step in the calculator because I get the most exact answer out of it. So when I do that, to 1 decimal place, I'm going to get 22.7 degrees. So that's to 1 decimal place. Okay. Example number 2 is an exam question. So we're going to do the same thing again, but usually in an exam, you have to work out your vectors first. So you're working with coordinates first, and then get your vectors for that 5 mark part at the end. Okay, so for part A here, we're trying to work out the vectors AB, so this one here, and the vector AC. So you can see they're pointing away from one another, so they're building you up to working out the angle here that's in between. So if I want to work out the vector AB, I've got to use my position vectors B take away A. So position vector B is -10, 18, 7, and position vector A is -2, 2, 5. And then work that out. So that's going to give me -10 add 2, which is -8. Then 18 take away 2, which is 16. And 7 take away 5, which is 2. All right. And then I want to do the same again for AC. So that's going to be position vector C take away position vector A. So position vector C is -4, -6, 21, and I'm taking away -2, 2, 5. So my vector AC is going to be -2, -8, 16. Alright, so that's part A done, and we're going to use those 2 vectors for part B. So I'm just going to write these up at the top. Okay, so we want to work out the size of angle BAC. So if I rearrange my first scalar product formula, I'm going to have cos theta is AB dot AC over the magnitude of AB times the magnitude of AC. So I've got all my working out to do before I can start to use that formula there. Okay, so the first thing I'm going to work out is AB dot AC. So that'll give me -8 times -2 plus 16 times -8 plus 2 times 16. And that will give me -112. Then I'm going to work out the magnitude of AB. So that will be the square root of -8 squared plus 16 squared plus 2 squared. So that will give me the square root of 324. And then lastly, I want the magnitude of AC. So that's going to be -2 squared plus -8 squared plus 16 squared, which again gives me root 324. Okay, again, don't need to worry about simplifying your surds there because we're a way to just substitute them into our formula. Alright, so I can have cos theta and then substitute my numbers in. So -112 over root 324 times root 324. And again, I'm just going to go straight to doing cos inverse of all of that. I'm getting a bit lazy, so I'm just going to do that. Now, you'll notice there's a negative here, and you don't normally do cos inverse or sine inverse or tan inverse of negative numbers because of CAS, but actually, in this instance, it's not the end of the world to do that because of the way that cos works. But hopefully, looking at it and seeing that it's a negative, you're going to get an obtuse angle here, and that's why it's negative, because the angle is going to be bigger than 90 and less than 180. So if I do cos inverse of all of that, again, to one decimal place, I'm going to get 110.2 degrees.